It's a long journey. Remember I said 30 years? It took me a while. Okay? If you have pair production, okay, and you understand that matter can be made, okay, if you assume for a moment, just for a little moment, that everything else is theory, and by the nature of that theory must be wrong, until it's been, okay, and theory must be wrong until it's proved. Because lots of theories, in the end, there's going to be one, and that's the one that's going to come true. So for the sake of thinking, that's what I do. I say, theory, fuck theory, just throw it out. I would rather not deal with theory because it could be wrong. Facts aren't wrong.
We're on the same page there.
Okay, so we know that there's pair production. So then we have to ask ourselves, let me see, if an electron and positron come together, they seem to annihilate. Of course they don't annihilate because you can't annihilate because we have the laws of physics, and the laws of physics are still pretty good. So you can't annihilate. You can say, well, they come together and disappear. That's possible. Or they transform into energy. You could do that, but they can't, in this case, of pair production because the energy does fly away. So that energy that was part of it, gone. Okay, same exact amount. Okay, so something was there. So you have to say, well, something had to be there because it turned energy into electrons and positrons. So now you have electron and positron. And then you say, well, first of all, they'll come together and they'll destroy each other. Well, maybe they won't. Let me see. Can we think of a way to keep them from meeting each other? Well, we can do it in a collider with a magnetic field. Actually, some different magnetic fields. We can adjust them and design them, and we can keep them from colliding. We can keep positrons alive for a long time. Well, is it possible for the universe to keep positrons apart from electrons? I mean, is there, well, it would take, yes? Achtung.
Can an Indian ask a question?
After I finish him?
Yeah, that's what I mean. After you finish.
Yeah, sure, but you got to sit down first.
When I'm standing, I'm as good as...
Stop answering my phones. Okay. So, is it possible to keep them apart? Well, let me see. In the Van Allen belt, can we keep positrons from electrons in the Van Allen belt? We have negative and positive particles flying around in different lines in the Van Allen belt. Let me see, where does that Van Allen belt go? It's part of the magnetic field of the Earth, and it goes inside the Earth.
Wow.
So it would be in the core of the Earth, not the core, the outer core. Most people say it's iron. I don't think so. I think it's plasma. Plasma will carry an electromagnetic field very easily, better than iron. Let's just say it's down there. Let's just say it's a field like Van Allen belt. So let's say inside the Earth we can keep electrons and positrons apart for a while, for a long while, waiting for them to do something. Well, what can they do? Let's just say this. I'm going into theory. None of this so far is theory, but I'm going to go into theory. Okay, and I apologize. Really, I'm sorry. I'm sorry. We made those particles in pair production out of something, not a thing. I say a field. We broke a field in half. We have the negative portion and the positive portion. And when it comes together, it wants to come together to form a full field. So I say, bam, it broke apart at the two halves of a field. Can't really get that in physics very much because they get pissed off when they say, oh, I get half a field. That's not possible. What's an electron? Anyway. So anyway, you have two halves. But you had to have something to begin with. You had to have something to begin with, a full field, to break in half. So let's just say the universe is these prime matter particles. Ooh, I use the phrase. Let's say the universe is filled with these prime matter particles. Let's say it's made of them. Can you identify them? No, because they're complete fields and they're probably integrated in themselves, so you can't identify them, but they're there and you can hit them with a high energy photon and break them in half. And when you do that, you have matter. Okay, we You got these little things flying around, hit them, they make two pieces of matter. Before that, they're one little field. Billions and billions of little fields. The universe is filled with them. So small they can fly between atoms. Because they can. A little field that's enwrapped in itself like water in giant rocks. Except if you hit them, they break in half like a powder, like a, I don't know, popcorn. A cottonseed. They become a field, full out-facing field. But before that, they were in-facing field. I know, you're getting bored with this, right? Fucking physics, I'm sorry. So let's say it's an in-facing field. Let's say the universe is filled with them. Well, guess what? Maybe those fields can be attracted by either an electron or a positron. Let's say they can be attracted by a positron because the outside of those fields is negative and the inside is positive. And maybe it can gather 919 of them.
Very exact number.
Yeah, it's a very exact number. Actually, what would be 920? It's actually 1,000 with a cube of 1,000 with 10 off each corner. And a positron on the inside. Since each one of those would be worth 2, negative and positive, that would be a proton.
Now we are doing something.
Ooh.
Oh, no.
Wow.
Now, if that proton were to attract an electron, they couldn't annihilate because there's this big field around it, negative and positive. 919 particles around the positron on the inside. Geez, you know, we see a positive energy inside protons. We don't know what it is. I say it's a positron. Positive beta decay releases it. Bang. Where did that come from? It wasn't in there all the time, was it? Yes. It was in there all the time. So now we have a proton. And when we attract an electron with that proton, it can't join it. It must go around it, form a field around it, and we have hydrogen. And my friend, from hydrogen, we can build a universe.
All right.
Go ahead.
You took my mic.
You skipped my question about being, you skipped my question, or somebody else
About
got
water?
you sidetracked. No, about your position.
Oh, wait,
You sound like a field theory guy today, and you sounded like a ether guy, you know, when I first started reading your stuff.
If ether, you could translate ether into prime matter particles that are enwrapped electromagnetic fields, then I'm an ether guy. But since we didn't know what ether was then, and I think it's this now, sure, what the fuck. I don't care. It means nothing to me.
Okay.
You know what I mean?
We've achieved unification.
Yeah.
We have time for a few more questions.
Yes, sir.
These two people are ready too.
Okay. Oh, here.
He gets it first. He gets it first.
Oh, he's already been here.
No.
By the way, you guys notice that I'm speaking English, not that funny science talk.
I heard some French there.
No.
So, particle pairs expanding Earth. Does that explain everything, or is there more work to be done in solar?
Everything.
All
It
universe.
explains everything. I hate to say that. I hate to say that, but it does explain everything. Look, understand, this is how science has traveled this merry little pathway. We've traveled back in time. We said everything is made out of everything. It's made out of all this other stuff, and then we discovered that it's made out of electrons, protons, and neutrons. And so we looked at that and we said, hey, we can find out how the universe is made. It's electrons, protons, and neutrons. And then, like monkeys with shiny stones, we discovered some other particles. Hey, here's another little quark. We have quarks. We have these things over here. Let's investigate these things. Excuse me, did you guys forget your job? You're down to 3 particles. Let somebody else work on that. They're parts of particles, whatever the hell they are, let them figure it out. Your job is to take it from 3 to 2 to 1 to 0, because that's how we understand the way the universe works. If we're not doing that job, what the hell are we doing? I'm discovering a particle. I think I have another particle over here. Screw you with your particles. You know, maybe it's a part of a particle. Maybe it's the electron before it becomes an electron. Maybe it's a neutrino. Maybe that's what an electron is before it becomes an electron. There's all these little things that you can go off and do. What happened to the job?
It takes a lot of particles to screw